Okay, so we went over 5 reaction types. The 5 reaction types for synthesis. Okay, synthesis is 2 elements combining to form a single compound, or in other cases it could be 2 compounds combining to form a single compound, but that's pretty rare. Okay, but we do have 1 or 2 of those actually in this sheet. Decomposition, where a single compound breaks down into its parts. Okay, combustion reaction, where a hydrocarbon, so carbon and hydrogen, react with oxygen and they burn and they make carbon dioxide and water. And then we have single replacement, where an element reacts with an ionic compound to produce a new ionic compound in a different element, and a double replacement, where 2 ionic compounds react and form 2 new ionic compounds. Okay, so what kind of reaction is number 1? It's a single replacement reaction. Iron is an element. It's reacting with hydrogen chloride. Hydrogen is listed first, so this is behaving as a metal. That makes that an ionic compound. So we are definitely looking at a single replacement reaction. Okay, writing it out in words, this would simply be iron. Do I need to write a Roman numeral after iron? Not when it's an element. Elements don't have charges. Okay, but if it was in a compound, like on the product side, then I would need to figure out which Roman numeral to put in there. Okay, so iron plus hydrogen chloride, okay, is going to give us iron 2 chloride, okay, plus hydrogen. How did I know it was iron 2?
Sorry for the interruption. So could we have grade 10, last name H through L? Could you please come to the cafeteria to get your picture taken?
Okay, well, I knew it was iron with the 2 charge because I simply did the math, right? Chlorine is a -1. There are 2 of them, so that's, I'm going to need positive 2 charges. There's only 1 iron to get it from. That's how I do it. Oh, we lost half the class. Okay, what about number 2? What kind of reaction is that? It's a synthesis reaction. Okay, we got 1 element reacting with another element to form a compound. Okay, so that'll be sodium. Oh, I didn't balance the first one. Oops. Okay, what should I balance first in the first one? Yeah, I can balance the chlorine or the hydrogen. They're both 2s, but chlorine came first. So, okay, there's 2 chlorines here. So what needs to go here? Does that fix the hydrogen problem as well? We're done. Okay, that's all there is to that one. Okay, back to number 2. Sodium plus chlorine. Okay, does the fact that chlorine has a 2 beside it change its name? Nope, it's an element still. That's one of the special elements, right? So we still write it that way. Okay, and that's going to make an ionic compound, sodium chloride. Okay, there's only one thing not balanced right now. What is it? Which one? Chlorine. Yeah, looking at the next one. So chlorine is out of balance. There's 2 here. There's only 1 here. If I put a 2 there, that makes the chlorine work, but what is it? What else does it do? Yeah, now I got to go back and balance the sodium because that puts it out of balance. Putting a 2 there will make it work, and now the whole reaction is also balanced. Okay, is this ringing a bell from the other day? I know it's been like 3 days since we looked at a chemical reaction, so. All right, what kind of reaction are we looking at in number 3? Simple decomposition, right? We got water breaking down. Okay, I either write SD, usually I write decomp just because SD can be confused with SR. Okay, so decomp, we got water, hydrogen, plus oxygen. Okay, and what's not balanced right now? Oh, I think hydrogen's okay right now. There's 2 on each side. Oxygen's not balanced, right? There's 2 over here, okay, and there's only 1 here. So if I put a 2 there, that makes the oxygens work, but how many hydrogen do I have now? 4, so what needs to go here? 2, okay? And that one's done. Okay, what was the other one I said to do? 6? Okay. All right, so for number 6, okay, we've got bromine acting as an element, okay, reacting with sodium chloride to make sodium bromide and chlorine. Okay, what kind of reaction is that? Single replacement. All right, what should I balance first? Reed, what should I balance first? Yeah, the bromine. I could balance the chlorine too, they're both 2s. Okay, so I've got 2 bromine over here, so what needs to go here? Okay, when I do that, how many sodium does it give me? Okay, so what needs to go here? Does that fix my chlorines? Okay, we're done. Okay, it's just back and forth to do the balancing. Okay, all right. Let's have you guys try. This one's tricky. That one can be tricky too, for balancing, not for naming. Okay. Let's have you guys try 8, 9, 10, and 11. Just because the balancing on those is a little bit trickier. See how you do with those. Okay, so first off, even the type is a little bit tricky here. Would you agree? Right. But the general form for at least number 8 is still that 2 things are combining to form a single compound, which would still mean it's what type of reaction? It's still a synthesis reaction. In the end, we only have one product. 2 things are combining to form a single product that's still a synthesis reaction. It's a slightly more complex synthesis reaction, but it's still synthesis. Now, if I'm writing this out in words, everything in here is molecular. So I've got sulfur dioxide plus oxygen gives sulfur trioxide. Okay, everybody all right with that? Okay. Is the balancing tricky? It is a bit. Because oxygen is in every single part of that reaction. Okay? But when we're balancing, we're still only concerned with, do I have the same amount of oxygen on the product side as I have in total on the reactant side? Okay? So if I'm looking at this equation right now I have 4 oxygens on the reactant side. 2 here and 2 here. And on this side, there are 3. What's the lowest common multiple of 4 and 3? 12. So that's where I'm going to start. I might have to reduce later, but I'm going to start by trying to make sure I have 12 oxygens on both sides. Okay? So what do I have to put in front of sulfur trioxide? A 4. All right. When I do that, that gives me 4 sulfur. So what do I have to go back here and do? Put a 4 here. All right. So I've got 12 oxygens over here. And right now, I have 4 times 2 is 8, plus 2 is 10, which isn't enough. So what needs to go here? I actually need 4 more oxygens. What do I need to put here? A 2. Okay. Is it balanced now? Yes. Is it right? No. Why isn't it right yet? What can I do with those numbers? I can reduce them, and I have to. Okay? So when you're balancing, always be on the lookout for that. You may have to reduce your balancing numbers. It happens sometimes. We did the smartest thing we could do, okay, to get it balanced, find the lowest common multiple, but it actually wasn't the lowest common multiple for this reaction. 6 was, not 12. Okay? So what I do instead is I just divide everything by 2, okay, to bring that down to its lowest terms. Okay? That's probably about as tricky as your reactions are going to get, okay, for balancing. All right, is it a similar thing here? Yeah, it is a similar thing here. All right, so if I'm naming this stuff, this would be carbon monoxide, okay, plus oxygen gives carbon dioxide. Okay, so I've got to balance this thing. I've got 3 oxygens on the reactant side. Okay, there's 1 here and 2 there, and I've got 2 over there. What's the lowest common multiple? 3 and 2, lowest common multiple? 6. Okay, so I'm going to go over here and I'm going to make sure I have 6 oxygens on the product side. Okay. Am I still following my rule of going with the biggest number when I start this? I am. I'm going with the biggest number still. Oxygen is by far the biggest number in the reaction. Okay, so now that I've got those, I've got that 3 here, I've got to come back over here and make sure I put a 3 there. Okay, now that's going to create a bit of a problem for me, isn't it? Because now I have an odd number here. Okay, that's going to be possibly an issue for me, okay, because I don't have any way to make it even. So I got to start over again. Okay, sometimes that happens. So what I'm going to do is, instead of using an odd number, I'm going to see if I can make this work with an even number. I'm going to try putting a 2 here. Okay? When I put a 2 here, what needs to go in front of this? Okay. Is it balanced? It is. Okay. It's now balanced. I have 2 carbons on both sides. I have 4 oxygens over here. 2 times 1 is 2, plus 2 is 4. It works. Okay? So sometimes that lowest common multiple thing doesn't work, and then you've got to think outside the box a little bit. Okay? All right, how many people have number 10 done? Okay, I'm going to give you guys a couple more minutes to get 10 and 11 done, and then we'll have a look at those. On number 3, we have aluminum, Al, and oxygen. How do I write oxygen when it's by itself? Right, this is the tricky part of going from word to formula, right? We have to remember, oh, that's a special element that comes as a 2. Okay, and it's going to make aluminum oxide. Okay, here's the other tricky part about going from word to formula. What do I have to do with that? I have to drop and swap, because I have to recognize first it's an ionic compound, and secondly the charges aren't balanced yet. Okay, -2 plus 3, so we got Al2O3. These are the things that, man, those little details, if we miss them, we're not going to get the balancing right, the reaction's not going to be right. Okay, so we really have to be careful when going from word to formula. All right, now that I've got that done, okay, I can start looking at my balancing. Right now, the biggest number is 3. Okay, and it's on the oxygen. I got 2 oxygens on the other side. What should I do?
Sorry for the interruption. So we're ready to start with grade 11, last name A through D. Could you please come down and get your picture taken in the cafeteria?
Okay, if I got a 3 on one side and 2 on the other, how do I balance 3 and 2? 6, yeah. 6 is the lowest common multiple. So what do I need to put in front of aluminum oxide? A 2, right? So now I have 6 oxygens over there. Okay, if I come over here, I can make sure I have 6 oxygens over here. What haven't I balanced yet? The aluminum. How many over there on the product side? 4. So what needs to go in front of this? A 4. Perfect. Okay, and I can't reduce those numbers because 3 can't be reduced. Okay? Everyone all right with how that one works? Okay, I'll give you a few more minutes and then we'll go through another couple here before class ends. Okay, let's look at 4 and 7 here. We had 4, 7, and 9, right? That's the ones we were doing? Okay, so for number 4, phosphorus. How do I write phosphorus when it's an element? P4. Okay, how about oxygen? Okay, and that's going to produce phosphorus pentaoxide. That stuff. Okay, everybody all right with that? All right. What should I balance first? What's the biggest number? 5. 5 is the biggest number. So I should balance oxygen first. I got 5 on one side, I got 2 on the other. What's the lowest common multiple? 10. Okay, so I put a 2 here. Well, that isn't going to work. Why not? It doesn't balance my phosphorus. Okay, so maybe I'll try the phosphorus first. That's what you have to do. If that first rule where you go with the biggest number doesn't work, then pick something else. Okay, the only other thing in this one is phosphorus. So there's 4 over here. Now there's 4 over there. How many oxygen are there? 20. What needs to go in front of this? Okay, and I can't reduce that because this is a 1. I can't reduce 1 any further than that. Okay. All right. Oh, we didn't identify the reaction types. What kind of reaction is number 3? What kind of reaction is number 4? All right. Okay. Okay. How many people have done 7? Okay. So calcium oxide, CaO. What kind of compound is that? It's ionic. Is it dropped and swapped correctly the way I have it written? Yes, it is. Okay, and it is because this is a -2 and this is a +2. They already cancel each other out. Okay, and it's going to react with magnesium chloride, Mg with Cl. Is that dropped and swapped correctly? It's not. Okay. So this is a 2+, this is a 1-, MgCl2. All right, that's going to produce magnesium oxide, MgO, -2 +2. Is that good? It is. And calcium chloride, CaCl, -1, +2, CaCl2. Okay, this is why you got to get super quick at being able to do those formulas for the compounds. All right, what kind of reaction is that? Double replacement. What should I balance first? Nothing. Why should I balance nothing first? Because it's already balanced. Okay, it's 2 chlorines on each side. There's 1 oxygen, there's 1 magnesium, and 1 calcium. Okay, on all sides, it's already done. Okay, we are going to spend some more time on this, okay, in the coming days. Here's the plan. Don't back up. Okay, plan going forward. Monday, we're going to work on reactions, and hopefully by the end of the period, we'll be looking, actually, not quite the end of the period, about halfway through the period, we'll be looking at being able to predict the products when only given the reactants. The last half hour of Monday will be our pre-lab. Tuesday, lab on reactions. Rest of the week, reactions, reactions, reactions. Then the week after that, mole equation, mole equation, mole equation. And your unit exam is going to be October 6th, I think. If it's not October 6th, it will not be earlier than October 6th. If I have to bump it, I will bump it away. Okay?